we're getting into today is solving quadratics. We know and we remember from Algebra 2 that we can solve quadratics lots of different ways. We can do factoring, which we've already done in here. We can do the quadratic formula. We can solve by taking square roots, and we can solve by completing the square. So today is taking square roots and completing the square. Taking square roots and completing the square both don't work every time. Factoring is my favorite way, but it doesn't work every time. The quadratic formula will work every single time no matter what, and that's the one that we'll get to tomorrow. So after we get them all covered tomorrow, then you'll be able to pick whichever method you want, and it won't make any difference to me. Even if the directions say solve this by completing the square, you can just ignore that and solve it any way you want. But for each individual lesson, we're going to learn that way so that then you'll have the freedom to choose which way you like the best. Alright, so starting off here, pretty simple, pretty straightforward. This says m squared equals 64, and we're just told to solve. So we're just trying to figure out what m is. And you would say m is 8. And I'll say that's half right. Very good, Aaron. It could also be negative 8. Okay, put the plus minus out there. Zane, very good, because we know that 8 squared is 64, and we also know that negative 8 squared is 64. So what we actually did to get that, what we're going to see throughout our lesson today, the first thing says square root property. My variable was being squared, so I just undid that by taking the square root. And anytime you do a square root, you can have the plus or minus. So we're going to write that sign a lot today, plus or minus. Now, if you want to, that's how I write it, how I circled it, plus or minus. You could actually write them both out. It's negative 8, comma 8. If you wanted to write it that way, that's fine. Okay? Pretty easy there. Let's add a few steps, a couple steps here. This one says 3x squared minus 54 is equal to 0. Now, this still falls in the category of the square root property. 3x squared minus 54 is equal to 0. Still falls in the category of the square root property, but there's some work to be done. What do we need to do to this? How would we start? How would we do that? Rachel said get x by itself, and that's fabulous. Before we divide by 3, we would add 54. So, gets us 3x squared is equal to 54. So we're good to go there. Now we're ready for Zane's second step. My x is being multiplied by 3. So we're going to divide by 3. What's 54 divided by 3? Not 16.
18.
18. So we got x squared equals 18. Now this is where the last problem's, the first one that we did started off at. But this one's not as friendly as the first one because 18 is not a perfect square. My x is still being squared, so I'm still going to undo that. So x is going to be plus or minus whatever the square root of 18 is. So this goes into those worksheets that you've done the last few days, trying to figure out how to break 18 down. What's the biggest perfect square that will go evenly into 18?
9.
9, very good. So this will be x is plus or minus. The square root of 9 is 3, so we bring a 3 out. And the 2, 9 times 2, stays in the house. Let me write that because I feel like I need to write that still. 9 times 2. And then the square root of 9 was 3. All right on that? Square root property. All right, this one says the quantity of 3x plus 1 squared is equal to 2. All right, what's different about this one? Pay attention, Kayla. What's different about this one? Good, that whole side on the left is being squared, what Rachel said. Not just one x like on the previous problems, that whole binomial is being squared. So what would we do to start solving this one? What are your thoughts on that? Okay, if I were going to attack that squared, which Rachel is talking about, I could, but it wouldn't be by distributing it. It would mean I would have to write that binomial twice and FOIL it. And then that would get into tomorrow's lesson, which would be the quadratic formula. So today we're doing square roots. So how about just undo that squared? Is that all right? square root the whole thing, so I would have square root and square cancel out, so just 3x plus 1. Over here, I got to have the positive or negative square root of 2. 2 is not a perfect square. It doesn't have 1 in it. It just stays in the house. Now I'm still, even though it's a radical on that right side, it doesn't mean I'm going to do anything any different. So what would I do to start getting the x all by itself?
Subtract 1.
Good, subtract that 1. Now, be careful about how you write it when you subtract that 1. I always put it in front like that, because if I don't, sometimes I get messy and I can't tell if it's underneath the radical or not. So that's why you'll see it in front most of the time, so you're sure it's not underneath the radical. All right, then you got one more step there. What are we going to do in our last step? Got it, kid. Divide everything by 3. So x is negative 1 plus or minus the square root of 2, all divided by 3. Now, talk about different types of answers. That's what's called the exact answer, because I didn't have to round or do anything at all to that. If, do you know what you're doing when you're solving a quadratic? A quadratic is a parabola, so you're finding the 2 places it crosses the x-axis, right? Like that little picture under up there, right? So if I'm actually, that could be like the flight of my golf ball. So if I'm actually trying to locate my golf ball and you tell me that I need to go negative 1 plus or minus the square root of 2 divided by 3 feet, I don't have any idea what that is. I mean, who does know what that would be close to? But you could put put the square root of 2 as a decimal, and I could probably be able to find the golf ball. But it's all up to how the question, what it tells you to do. If it says give the exact answer, that's the exact answer. If it says approximate, that's when you get to hit the square root of 2 in your calculator and round it to a decimal answer. Okay? Today we're going to be giving exact answers, so we don't get to round today. Alright, now getting it to this phase right here is what we're fixing to get into using completing the square. Okay, so if I gave us a problem that said x squared minus 2x minus 10 is equal to 0 and said solve. Alright, here's where we're going with this today. Tomorrow we'll look at the quadratic formula and the rules will change, but for today we're going to use completing the square. That means I want to be able to take that trinomial, rewind the page here, and I want to be able to have it written as a perfect square like that. I want it to be able to be a binomial squared. So in order for that trinomial to be a binomial squared, I got to have some stuff in place. So my first term has to be a perfect square. Is x squared a perfect square? Yes, x times x. Very good. My last term has to be a perfect square. Is 10 a perfect square? No. Okay, so that's where we'll start the show at. What we do, remember that's ax squared plus bx plus c. Remember that? So my c, 10, is not a perfect square, so I call that a bad c. So we need to get rid of the bad c. We need to move it to the other side. What operation do we do to move that bad c to the other side? A kid, Mr. Ferguson, we add 10. So, oh, not with a highlighter. So x squared minus 2x equals 10. We added 10 to both sides. Now, here's a new formula. Well, it's not new, we did it last year, but new this year. A new formula that you're going to need to write down, because we got to find a good c now. We got rid of the bad c. We need a good c. To find your good c, write this down. You take your b, you half it, and then you square it. And that'll get you your good c. Okay, so what is our b in this problem? No.
Negative 2.
Negative 2. It's the coefficient with that, Zane. You're in the right spot. So we do negative 2 divided by 2. That gets us negative 1. And then we square that, which gets us 1. So our good c is 1. So I got to put that in the c spot. So I got x squared minus 2x plus 1. Now, whatever you do on the left, you got to do on the right. So I put a plus 1 over there on the right. And now remember, my whole goal was to be able to write that trinomial as a perfect square binomial. It's a lot of nomial words there, isn't it? I can now. As I start through that same checklist again, is my first term a perfect square? X squared, x times x, check. Is my last term a perfect square? 1. 1 times 1, check. So I take the square root of my first term. I take the square root of my last term. I take the first sign, minus 2x, so I got a minus there. On the right side, 10 and 1. Now we're to where that last problem started. It took us a little bit of work to get there. We're ready to get rid of that squared now and start solving like on the last problem. How do we get rid of that squared? So x minus 1 is the positive or negative square root of 11. You got one step left. Get the x all by itself. Get rid of a minus 1. Add a kid plus your 1. So x is 1 plus or minus the square root of 11. Alright, this one says x squared plus 8x plus 10 is equal to 0. Same deal, we want to be able to rewrite this as a perfect square binomial. Parentheses, it's a perfect square. So let's go down the checklist. Is my first term a perfect square? Yes. Is my last term a perfect square? No, 10's not a perfect square. So we got to get rid of 10, so we subtract it. X squared plus 8x equals negative 10. So we got rid of the bad c. Now we got to find a good c. Our good c is equal to our b. What's our b?
8.
8. Divided by 2 is 4. And then square that. Get you 16. So we got to add 16 to both sides of that equation. So x squared plus 8x plus 16 equals negative 10 plus 16. And yes, you can just write 6 over there. First period started panicking. They thought I couldn't just write 6. Negative 10 plus 16 is 6. Alright, so now, since we got a good c, we can rewrite this as a perfect square. What's the square root of x squared? X. What's my first sign? What's the square root of 16? 4. And over here I got negative 10 plus 16 is 6. Okay, not too bad now. You're ready to do what?
Get rid of that.
Get rid of the squared, so square root it. So x plus 4 will be the positive or negative square root of 6. Now move your 4 over. X is negative 4 plus or minus the square root of 6. 6 doesn't break down, so that's it. Alright, this next one tricks a lot of people. See if it'll get you. X squared plus 3x minus 1 is equal to 0. Alright, solve, completing the square. Is my first term a perfect square?
Yes.
Yes, x times x is x squared, so check on that. Careful here. Is my last term a perfect square?
No.
Good, it is not because of that negative. Negative 1, you can't multiply something by itself and get a negative. Anything times itself always equals a positive. So even though 1 is a perfect square, that's a negative 1. Negative 1 is not a perfect square, so move your 1 over. So you've got x squared plus 3x equals 1. Now you got to get a good c, so take your 3, and this one's going to be a fraction. We're going to leave it in fraction form. Take your 3 and half it, and then square it. So that's going to be x squared plus 3x plus 9 fourths. 3 squared is 9, 2 squared is 4. equals 1 plus 9/4. It's always easier to leave that in a fraction form because it's real easy to know what the square root of the top and the square root of the bottom is. If you put it as a decimal, it's harder to figure out. But now I got square root of the first one, first sign, and here's why I said leave it as a fraction. And tell me if this doesn't look familiar. The square root of 9/4 is 3/2. Hadn't I already used 3/2 up there somewhere?
Yeah.
Yep, same spot over there where I squared it. 4/4, that's what 1 is. 4/4 plus 9/4 is 13/4. We're ready to solve. Now do your squared. So x plus 3/2 is equal to, does 13 have a perfect square in it? No, so it's going to stay there, square root of 13. What about 4? It's the same, square root of 4 is 2, right? So I can throw that 2 down there on bottom. Okay, so now the only thing we got left to do is move that 3/2 over. So I could write x equals negative 3/2 plus or minus square root of 13 over 2. Some people will leave that, and that's correct. There's another way you could write this since they both have a denominator of 2. Since it's a common denominator, you could write it, good, just write it over 2 once like Zane was saying. Either one of those would work. That was gross.
Excuse me.
Alright, now we got to look at what to do if our A is not a perfect square, if our first term is not a perfect square. This one says 2x squared minus 4x minus 5 is equal to 0. Alright, so we already failed our checklist. 2 is not a perfect square. So I need to change that 2 to something that is a perfect square, like a 1. What could I do to that whole equation to make that be a 1x squared?
Divide by 2.
Divide it all by 2. So I'm going to have x squared minus 2x minus 5/2 is equal to 0. So now my A is a perfect square, hot dog. What about my C? No, wait, Jose, we need to move it out. So we're going to add 5/2 to both sides. So we got x squared minus 2x is equal to 5/2. Okay, now to get our good B, or excuse me, to get our C, take your B, half it. Negative 2 divided by 2 is negative 1. Square it, that's 1, so we're adding 1 to both sides. We are right there. So on the left, this will be square root of x squared. Haven't paid attention. Minus square root of 1, all squared. 5/2 plus 2/2 is 7/2. Okay, so we got, what do we do here?
Take the square root.
Good, good. X minus 1 is equal to positive or negative square root of 7/2. Now, last time we had a 4 on the bottom, and that was a perfect square, so that radical went away. A 2 on the bottom is not a perfect square, so we're going to have more work to do to that in just a second. But let's go ahead and move our 1 over first. So I'm going to have x equals 1 plus or minus the square root of 7/2. Now, square root of 7/2. You just said we can't have a square root on bottom. What would I multiply by to get rid of a square root of 2 on bottom? What cancels out a square root of 2? What would you multiply by to get rid of the square root?
2.
Square root of 2, that's right. So this would be like, if I multiplied both top and bottom here by the square root of 2. So that would make square root of 14 over 2, right? So I've got x equals 1 plus or minus square root of 14 over 2. That's correct. That probably isn't going to be a choice because here we've got a whole number and here we've got a fraction. One's the same as 2 halves, so I could rewrite that if I'm looking for a choice. I could rewrite that as x equals 2 plus or minus the square root of 14 all over 2. That'd be the same thing, wouldn't it? Because that 2 divided by 2 would get you that 1. So that might be in case you can't find a choice what you would do. Alright, last thing we got to look at is when we get an I with our answer. Give us an easy one because they work the same. I got x plus 5 squared equals negative 100. Alright, look where we are on this problem. The hard work's already been done. It's already written as a perfect square binomial. So you don't have to worry about getting rid of a bad c and finding a good c. That's already done. Okay? So what's your first step here now that you've already got it as a perfect square binomial? Square root, nice job. So it gets me x plus 5 is equal to the positive or negative.
Please excuse interruption. I need all senior boys basketball and managers to please go to the gym.
Positive or negative square root of negative 100. Now, other than the negative, it's alright friendly because 100 is a perfect square. What's the square root of 100?
10.
10. What happens when we have a negative underneath the radical?
It becomes imaginary.
Good, good, good. So we got x plus 5 equals positive or negative 10i. Okay, so I've got one step left to do.
You gotta get that x by itself.
Tell me how.
Minus 5.
Good, subtract your 5. Now, it is super important now that your real number comes first. Because remember, standard form, real number is always before the imaginary. Alright, solving quadratics. This should be a fairly easy unit for you because we spent a whole heck of a lot of time in Algebra 2 doing it. So it shouldn't be that big of a deal. Tomorrow's the quadratic formula, and we'll sing the song again and get that back in our brains again. That'll be what we look at tomorrow. Okay? Very good? And that's it.